This is current and DC circuit. The figure shows a circuit used in an experiment to measure the current in a lamp for different values of the PD across the lamp. State the name of the component P.
Variable resistor.
Very good. You call it rheostat, or you can also call it on the axis below, sketch a graph of current against PD for a filament lamp. It's a memory function. And if you remember that filament lamp does not follow Ohm's law in a way that when temperature increases, when you switch it on, its temperature increases and consequently its resistance increases. So you can look at the notes also. But what was the rule? If you want to show resistance is increasing, the graph should be bending towards current axis or voltage axis.
It would be a decreasing gradient.
This is the rule. If you want to show, and these are all in your notes, and that is where you have to carefully and strongly learn the notes. You are already using, I think, MS books. They provide a notes document also. If you want to buy that book, you can also get that, but actually handwritten notes are more effective. Also, I can provide you a digital file of the notes. Achha, temperature increases, resistance increases, and sketch should be bending towards voltage axis. So I am going to draw the sketch. This is the sketch. The sketch is bending towards the voltage axis.
Yes.
So what is the rule, Zainab? Can you please repeat? When resistance increases, the graph is bending towards voltage axis.
For C part.
No. The sketch part, I'm talking about B part. What is the rule? When resistance is increasing, the graph should be bending towards voltage axis. And when resistance decreases, the graph should be bending towards current axis.
Current.
State how the resistance of the lamp changes as the PD increases. So you will answer.
Resistance increases as potential.
Very good. Resistance explain how the graph in B shows the change you have described in C part 1. Graph is bending towards x-axis. Gradient is decreasing. Gradient is 1 upon r. Can you tell me what is the formula for gradient for a graph?
Y2 minus Y1 or X2
Not
minus
that one,
X1.
gradient, this one, simple basic form, logic one. Gradient in physics is simply y upon x. Can you tell me why I am taking 1 upon r, why I am not taking r? Because r is equal to v upon I. R is equal to v upon I. Is this question there in the book? Looks to be the same topic. Is it there in the book or not? After that, look at the second question.
It's not the same. No.
Yes, it's not there. Okay, fine. Now, please share the year number of the second question. If you want, you can write in the chat, or you can tell me.
Maybe. Everything.
Describe an experiment including an ammeter and a voltmeter to show the resistance of a wire varies with temperature. Draw. Achha, this is also an old question. Can you look for the last question, please? This is again an old question. Please look at the last question. The figure 10.1 shows a wire of length L and cross-sectional area A. State how the resistance of the wire in 10.1 depends upon the length. So do you remember the concept that resistance is proportional to length and resistance is inversely proportional to area? Resistance is proportional to length and resistance is inversely proportional to area.
Yes. Done.
Now, the cross-sectional area of a piece of metal wire is this much. This is the area given. The resistance of a 1 meter length of the same wire is 6.4. The wire is made from metal wire. The wire is made from metal W. The figure shows a solid cube of side 1. It is also made from metal. It's also made from metal W. Calculate the resistance between the two opposite faces. So let's find the area. It's a cube. Cube means all sides are equal. So this area will be 1 into 1. So area will be 1 centimeter square. Let's say it is A2. This is L1. This is A1. And what is asking? Calculate the resistance. So it means he's asking the second resistance. This is the second length. Read the question and help me to locate the formula. Meanwhile, I'm writing down the conversion. 1 meter is equal to 100 centimeter. Okay, now we should start working. What is the formula which should be helping us here? This is the formula. I have started putting the values.
Why did you add 1 meter?
Sorry. Length is initially length. The resistance of a 1 meter. I have converted meter into centimeter and the initial resistance is 6.4.
Okay.
And the second resistor is unknown. One is not necessary to be written. To copy these steps. Copy this working and get the answer.
Okay. And 4.8 times 10 raised to power minus 5.
Okay, what's the answer you're getting?
4.8 times 10 raised to the power of minus 5.
Minus 9.
5, 5.
The wire in part B is tabbed to a meter rule. The figure shows that a 1 meter length of the wire resistance 6.4 ohm is connected in series with a switch, a cell of electromotive force, and a resistor of resistance 9.6. Now it looks to be a wire circuit. 1.2 volt is the voltage, 9.6 is the resistance. The switch is closed. It means circuit is on. Explain what is meant by EMF. If this is a memory, what is EMF?
Energy transfer to electrical.
It is the energy dissipated. You have to learn the definitions just like memory, driving. A unit positive charge this is the definition. Calculate the potential difference across the 1 meter length of the wire. So there is a 9.6 ohm resistor. There is a 9.6 ohm resistor and there is a 1 meter wire. He has given us the resistance of the wire 6.4. He has given us the resistance of the wire 6.4 ohm. So we know in series, voltage is divided in the ratio of the resistors. In series, voltage is divided in the ratio of resistors. We have the resistors and we need to find the voltage. What is the concept? In series, voltage is divided in the ratio of the resistors. And is asking for 1 meter length, that is the resistance is given. So we should first recall our concept, because doing past paper, main thing is the concept. So let me recall the concept. In series, voltage is divided in the ratio of the resistors. This is the concept. If you have better to recall it, and that is the point to remember, that actually the main thing is notes. You have to remember, you have to learn all the notes. And now we can check the formula. Now, what are the two resistors? One resistor is 6.4 and the other resistor is 9.6. One resistor is 6.4 and the other resistor is 9.6. So I'm working on that. Acha. Now you have to be careful. I want to work out 1.1.0. What is the resistance of 1 meter resistance? What is the resistance of 1 meter wire resistance? It is 6.4. Okay. So I will be showing the formula in simple form like this. What is the total voltage in the circuit? 1.2. Very good. Now we have made the equation. Now put the values. Here is very careful thing. You have to see what is the 1 meter length of wire resistance. What is the resistance of 1 meter long wire? There are two resistances shown. What is the 6.4? Very good. This is a very tricky step. That 6.4 should be the numerator. 6.4 plus 9.6. 6.4 plus 9.6 into. Now solve this.
0.48 volts.
Can you please repeat? 0.48
48 volts.
484.
0.48. Yes.
Sorry, 0.484.
No, 0.48.
Not getting the word. Can you please write it? 0.48.
Yes. 0.48.
One input terminal of an oscilloscope is connected to the wire at point T. The 0 cm mark. Huh?
It's 8, 0.48.
You can write in the chat what is the right answer. No problem. One input terminal of an oscilloscope is connected to the wire. Okay, thank you. The other terminal of the oscilloscope connected to a sliding contact. Initially, this contact touches the wire at point P. Where is point P? Where is point P? Achha, it is on the same position. Oscilloscope we haven't done, but it is like presently we can consider it like a case here that we haven't done this topic. So this is a topic we have to do later, and you just mark on it as I am marking. Do all the marking which I am doing, and this will help you because you have to write in the paper. So you will have a habit. So write it and put a tag here later. Okay, now can you please move forward and you can see this question, this part. This part we are not doing. We are going to part number D. A second identical 1.2 volt cell is connected in parallel with the cell in the circuit. State one advantage of using two cells in parallel rather than a single cell. So again, this comes to be memory. You have to learn the things in parallel, less resistance. Less heating and more backup time.
Done.
State and explain the effect on the trace in C. This is again a question which is related with the CRO. CRO is our topic in the coming chapter, and we can discuss it later. Then this question is over. Okay, now you have to help me to look the second last question. Go back and look for the second last question.
Okay. I've written in the chat.
Yes, thank you. And we have June 20, paper is 22. Okay. I think this is the question, right? The figure shows the circuit diagram. This is June 2022. June 20. Is it the question? Is it matching?
Yes.
The figure shows the circuit diagram of a temperature gauge. It contains an ammeter, a thermistor, a fixed resistor, and a battery. Okay, they have given everything. The current is measured at different temperatures and a graph of the results is shown in the figure. State how the resistance of the thermistor changes with temperature and explain how it shows in this graph, in this change. The graph is bending towards current axis. Graph is bending towards current axis. So this is to remember. Can you please repeat the concept? If a graph is bending towards current axis, it means resistance is decreasing. If a graph is bending towards voltage axis, it means resistance
The resistance increasing.
Increasing. Very good. Now you have to copy this.
Done. I've copied it.
Okay. Resistance and current are used for the measurement of temperature. One other physical property that is used for the measurement of temperature. Said one other physical property that is used. So you can label anything like expansion of a liquid, volume of a gas, which actually something which respond temperature. Resistance and currents are used for the measurement of temperature. State one other physical property that is used for the measurement of temperature. A temperature scale involves the use of fixed point. This is thermodynamics. This is thermal physics. So we haven't done it yet because this is a later chapter. C part. At 80 degree, the PD across the thermistor is 3.6. He says, what is meant by PD? Can you please give the definition? It is?
Work done or energy change.
It is the work done per unit charge to convert calculate the resistance of the thermistor when the temperature is 80. So we have to see the graph. Temperature is 80. And if you have the book, so please read it for me. And meanwhile, I'm also trying to read it.
Okay.
It looks to be 0.01211121314. Looks to be 0.014.
Yes, 0.01.
So 0.014 is the current.
Yes.
What is the voltage? 3.6.
3.6. Voltage 1.
Put it in
257.14.
Sorry,
257.14.
0.14.
Yes.
So I've rounded it for 2 sig feet. The electromotive force is a big question. The electromotive force of the battery is 25 volt. Calculate the resistance of the resistor R. So we have the resistance of the thermistor, and we have he has given us the EMF of the circuit source, 25 volt. So I have to add both the circuit components, R plus resistance of what is the resistance of the thermistor is coming to be 260. The current is point. Now you have to solve it. Let's put the unrounded value here. So get the answer. You can try it, and we will inshallah verify you can complete the working and share the answer with me also. We are stopping here, and we will do it inshallah in our next class. Allah Hafiz.